Hey, this is lesson 10.3b. It's the last lesson in module 10. So generating equivalent expressions. So we are still writing, finding, matching equivalent expressions, okay? This time we're going to do it by doing something called combining like terms. So we are still generating equivalent expressions, still lesson 10.3, but the second half of this lesson, lesson B, is combining like terms. This is a very important lesson, so I want you to do a lot of practice on this, okay? First, let's talk about the parts of an algebraic expression. It's important to know these words so that you know what you are combining. When it says combine like terms, you need to know what that means. So let's start with the word term, okay? What is a term in an algebraic expression? Well, the parts of the algebraic expression that are separated by addition or subtraction signs. Those parts are called terms. So let me give you an example. If you had this expression, 2x cubed plus 4y minus 3, each of these is a term. Even the 3 is a term because this and this and this are separated by addition or subtraction signs. So each of these is a term, okay? Now let's talk about the word coefficient. Coefficient. C-O-E-F-F-I-C-I-E-N-T. Coefficient. So what is a coefficient? A coefficient is the number. It's the numbers that are multiplied by at least one variable. So a coefficient is the number that you see right in front of a variable, okay? For example, if you see 9x squared, or you see 7y, or you see 10ab, that's two variables. These are the coefficients. The 9, right? The 7, and the 10. The 9, the 7, and the 10 in these examples are coefficients because 9 is being multiplied times x squared. So that's the 9 is being multiplied by a variable. The 7 is being multiplied by y. So the 7 is being multiplied by a variable. The 10 is being multiplied by a and then b. So it's being multiplied by two variables. So coefficients are the numbers that are multiplied by at least one variable. So the coefficient is the number right in front of the variable. If you see a variable that has no coefficient, it actually does have a coefficient. The coefficient is 1. We just don't write the 1 because we know that x times 1 is x, right? From the identity property. So all variables have a coefficient. If you don't see it, the coefficient is 1, okay? The last thing we're going to learn is what's called like terms. And again, we are combining like terms in this lesson. So what are like terms? So if each of these is a term, and this is a coefficient, like terms are terms with the same variable raised to the same power, okay? So if a term has the same variable to the same power, then those are like terms. Let me give you an example. If you see 7x squared and 2x squared, both of those terms have an x squared. It's the same variable to the same power. So those would be like terms. If you see 4y and 9y, Both of those have the same variable to the same power, which there's no power, right? So those would be like terms. Okay? So terms are each of the parts of an expression that are separated by addition or subtraction. So that's a term, and that's a term. Coefficients are the number that's right next to the variable, and it's being multiplied times the variable. If you see a variable with no coefficient, then the coefficient is 1. And like terms are any term that have the same variable raised to the same power. Okay, this is very important for you to try to remember these words. So we can make equivalent expression by doing what's called combining like terms. So let's talk about what that means. These are like terms. This term has an x squared. This term has an x squared. So those are like terms, same variable x to the same power 2. So that means I can combine them, which means I can do 6 minus 4. So if I combine those, an equivalent expression for 4x squared minus, or 6x squared minus 4x squared is 2x squared. Okay, equivalent expressions, those are worth the same value. All right, so I just did 6 minus 4, and I can only do that because they have the same variable raised to the same power. So let's do this one. Actually, let's do this one down here first. Let's do this bottom one. We have y plus 11x plus 7y minus 7x. So here's a y, here's a y. This is, remember, there's no coefficient, but that means the coefficient is 1. So 1y plus 7y is 8y. And I can do that because they both have the same variable raised to the same power. Then I have 11x minus 7x. And same, again, same variable raised to the same power. So I can combine them. 11x minus 7 is 4x. This expression right here and this expression right here are equivalent expressions. They are worth the same value. If you plug in the same number for x in both expressions, the same number for y in both expressions, you will get the same value. Okay, these are equivalent expressions. Now, let's come back up here. In this one, you see the parentheses with the 2 right in front of it. As soon as you see that, you know you have to distribute. You have to multiply using the distributive property first. So we're going to do that. We're going to do 2 times b. So we have 3a plus 2 times b is 2b. And then 2 times 5a, which is 10a. All right. Now I can combine like terms because I have a right here and a right here. 3a plus 10a is 13a, and then I have 2b here, 2b. I cannot combine the 13 and the 2 because they do not have the same variable. 13 has the variable a, 2 has the variable b, and I cannot combine those. Like terms says they have the same variable to the same power. These are not like terms, they cannot be combined. So that's as simple as you can make it. This expression right here is equivalent to this expression right here. Those are equivalent expressions. They basically are worth the same value. Okay, I just simplified this expression. It's now much shorter, but I will get the same value if I use this one as if I use this one. Okay, last one. I have an 8x squared, a 3x, a minus x squared, and a 2. So I see that one and that one have the same variable to the same power. So I can take 8x squared minus x squared. Remember, that's a 1. So I get 7x squared. And then I have 3x, which I can't combine with anything. And then I have 2, which I also can't combine with anything. So I cannot combine the 7 and the 3 because yes, they have the same variable, but the variables are not to the same power. Okay, so those are not like terms. And this one doesn't have a variable at all. So it's also not a like term. This is as simple as I can make this. These are equivalent expressions now. This one and this one will give you the same value. So this is just, again, a simplified because now we've made it a little bit shorter. That is simplifying by using combining like terms, and we generate equivalent expressions, okay? So you're going to do a lot of practice on this because combining like terms is a very important skill, okay? This is lesson 10.3b, generating equivalent expression using combining like terms. So remember, sometimes you'll have to distribute first and then combine like terms, okay?